Alright, YouTube community, this is Professor Tomney, and I am back with another Chem Complete episode. And today we're continuing some Organic 1 lectures. We're going to be talking about naming alkanes today. So alkanes are essentially nothing more than hydrocarbons, and they do not have a whole slew of functional groups present necessarily. So alcohols, ketones, anything like that. When you get to those specific functional groups, we would name that particular functional group. So like ethanol is a type of alcohol. So we're just going to focus on naming very simple, basic organic compounds to start with, and those would be alkanes. So how do we start with naming alkanes? There's several rules that we need to follow and understand. And the first rule is whenever you have an alkane or a hydrocarbon chain, you want to find the longest chain, which we will often call the parent chain. And when you find that chain, that is going to be essentially the chain's name that you're going to place at the end of the entire structure name. So find the longest chain. Again, sometimes you may hear this referred to, and I will often call it the parent chain. And determine how many carbons are in that chain. So for instance, if I have a structure that would look like this, okay, and I need to find the longest chain, I could start at any position. So in other words, I could start here at this carbon, I could start over here at this carbon, I could start down here at this carbon, or I could start here at this carbon. Any of the terminal carbons, I can begin counting from that point and moving forward. And the goal is to find the longest possible chain. So in this case, it's rather evident. We would start right here, or you can start on the other end. It doesn't matter which way you're going at the moment. It will in a minute. 2, 3, 4, 5, 6, 7, 8, 9. So this compound is going to be some sort of nonane. And the term ane comes from alkane, and then you're always going to have some sort of a prefix that goes along with that parent name. And the prefixes are meth, if you're talking about 1, and then we're just going to go down the list here. So F would be related to 2. Prop, like propane gas, would be related to 3. Again, with gas similarities, bute is going to be equal to 4, like butane. And then some of the more common ones that you could probably come up with, pent is going to be 5, just like pentagon, pentane. Hex is going to be 6. Hept is going to be 7. Obviously 8 will be oct. 9 will be non, N-O-N. And 10 is also fairly evident, which is dec. Okay, so you think of something like a decade, 10 years, dec would be 10 carbons. So if I were to take a look at this, these other portions that were not counted, they're still present on the molecule. They're just not part of the longest chain. And when we have these types of compounds that are hanging off, they have a special name. We call them substituents. And a substituent is essentially any part of the compound that is not the main chain. However, it should be found along the main chain itself. So right here, because this has 2 carbons, this would be considered an ethyl substituent. And right here, this has 1 carbon, so this would be considered a methyl substituent. So those prefixes again come from this list that we have over here. And I could start calling this, something ethyl, something methyl nonane. And that something is going to be the number that's associated with this. So that brings us to rule 2. And rule 2 is once you've identified or found the parent chain, you then want to make sure that you give the lowest possible number to all substituents. So when I'm looking at this, if I want to give the lowest possible number, take a look here. Right now, using the numbering system that I'm using, I have a 1, 2, 3, and when I get to 4, that's the location of my ethyl. So I have a 4 for the ethyl. I go 5, 6, and then I find the methyl at 7 right here. So I would have a 4-7 numbering system if I went that way. You can always go back and forth. So I can also look at it and say, here's 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have to get used to this, and it's very hard at first because many students are so used to going left to right. Whether you're reading, whether you're looking at math equations, whatever it might be, you can go back and forth when you're doing this. So you need to keep that in mind. So looking at it from this position, I go 1, 2, and then 3 would be the number for methyl. 4, 5, and then 6 would be for ethyl. Now it's important to realize that for the moment, right now, because we're not dealing with special functional groups, we do not give priority in terms of number to one group over another. So we don't say the ethyl is larger, so therefore we give it the lowest possible number. It doesn't work that way. You simply look at the possible sets of numbers, 4 and 7 or 3 and 6, and you pick out the set that offers the lowest possible numbers, so 3 and 6. So if I were to write out the full proper name of this compound here, I would be dealing with a 3-methyl and a 6-ethyl as far as the substituents. Okay, now that brings us to the third rule, which is that once I get ready to name these substituents, I'm going to list them, not numerically, but list all substituents in alphabetical order. And that's important because a lot of students think that when we're doing this, we just turn around and say, well, whatever is 3 comes first and then whatever is 6 comes after that because they're listing it numerically. Sometimes it may work out that way, but you should always be naming based on the alphabetical order. And the parent chain does not count when we're doing that. The parent chain is always last, so you don't consider, oh, nonane has an N. Okay, you don't worry about any of that kind of stuff. So now, if I were to give the full proper name here, I can use the rules that are present in order to give the proper name. So I would have, if it's 3-methyl and 6-ethyl, E comes before M alphabetically, so the ethyl will be listed first. So I would say that this compound is called 6-ethyl. Then I do the methyl, 3-methyl. Nonane. Okay, so that would be the name of that structure. So you have the first 3 rules here. There is another rule, and the 4th rule tells us that if we have more than one, we should use the proper prefix, more than one substituent. Okay, so if you have multiple of the same substituent, let's say it that way. If I have multiple of the same substituent, then that substituent is going to need a prefix itself. So what do I mean by this? Well, let's take a look at something like this. This will be another example. All right, so let's say I have this, and I also have this right here, right? So if I find the longest carbon chain here, I'm going to go ahead and say, all right, it would be going from this point to this point, and if I count them up, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm dealing with some sort of a decane, so I'll mark that up here just so I don't forget, right? My main structure is a decane. So then I come back down here and I say, all right, well, let's take a look at the specific numbering system. So one of them I'll keep in red, the other one I'll keep in blue. You should be able to already see which numbering system would be better, okay? But here's 4, 5, 6, 7, 8, 9, and then 10 would be on the end here. That's the decane, right? So if I reverse this numbering and I say I'm going to start 1 over here, 2, and then 3, 4, 5, 6, 7, 8, 9, 10, right? So using the red numbering system, I come across the ethyl at 5, so I would have a 5-ethyl. And then at position 8, I would have 2 methyls, right? So this would be an 8-8 because I have 2 of them. So if I go the other way and I look at the blue tells me that when I get to the methyls, I'm going to have 3 and 3 for the methyls. And then on top of that, if I continue along, I would get a 6 for the ethyl. Well, 3-3-6 is certainly lower than 5-8-8, and so we'll use the blue numbering methodology here. So what does that mean? It means that I'm going to have a 3-3, and now I have to use the proper prefix. So if I have multiple of the same substituents, I'm going to need a prefix associated with that. So if I have 2, I'm going to call this 3,3-dimethyl, right? So rule 4 tells me whenever I have more of whenever I have one or more of the same substituent, I need to use the prefix here, or I should say 2 or more, not 1 or more, right? So dimethyl, I could also have tri, and you could have tetra if you have up to 4. You could have penta or whatever if you get to 5. Usually you're not going to see a whole lot of examples that go past 4 when you start doing this sort of stuff. So 3,3-dimethyl, and then I would also have a 6 related to the ethyl. So now the question is, when I list this alphabetically, is it D, because D would come before E, or is it M? And because the di portion right here is referring to basically just a prefix, it's telling me how many methyls I have, it's really the methyls that are the substituent, I still rank this as M when I'm listing it alphabetically. So if I wanted to give the proper name here, I would call this 6-ethyl, because again I'm starting with the alphabetical, and then 3,3-dimethyl, and then I would have decane at the end, right? So that would be a situation where I have named that compound properly. So a couple of other things to keep in mind. If you have any sort of halide that's present, and we're not dealing with alcohols or anything special functional groups like that, but alkyl halides get named in the same way that alkanes do. And so you can just use the terminology chloro. You may have fluoro. Fluorines aren't quite as common as chlorines. Bromo and iodo. So you want to keep those in mind when you are working with your naming. Another thing that can come up, and will come up quite often, is what if I have a compound like this, right? It's cyclic. Well, how many carbons are here? 1, 2, 3, 4, 5, 6. So when I'm dealing with this is a cyclic compound. If I have 6, I might be tempted to name this hexane. However, this is not hexane, because if I had hexane, that means that these two compounds would be the same. 1, 2, 3, 4, 5, 6. I have 6 points there. This would be hexane, right? This is not hexane. This right here is known as cyclohexane. And that's important because anytime you have a ring structure, so like cyclopentane would be a 5-membered ring. That's a very ugly 5-membered ring. Let's fix that. Okay, if I have a 5-membered ring, I would have cyclopentane. So on and so forth. All right, now what happens if I've got a very large chain, and then coming off of that chain, I have a cyclogroup, right? Something like this. Well, in that case, if you look at this, the cyclogroup right here has 5 carbons. And then I take a look at the main chain right here. I have 1, 2, 3, 4, 5, 6, 7, 8. So when you're dealing with cyclic compounds that have long chains coming off, you're in one of two positions. Either the ring contains more carbons, in which case it will be the parent chain, or the chain itself contains more carbons, right? So this would be 8 versus the 5 carbons over here. So in this case, I'm really dealing with an octane, and the cyclo compound can be written as a substituent. So if it's off of the end here in position 1, I would go ahead and I would say that this is 1 cyclopentyl octane, right? So the cyclo group can become a substituent. And that's important to understand because you can go back and forth here, right? So if I have a ring where I have a smaller group that would be present, so let's say I have a 6-membered ring and I've just got this chunk coming off of here, right? This is only a 2-carbon chain, whereas this guy would be 6. So now the cyclo is the main parent chain, and I would have cyclohexane. So what about this? Do I need to include a number with this because of this group? So it would be ethyl, right? So do I need to state that this would be 1 ethyl because I'd be starting it in position 1? Well, the answer is no. You don't have to really put a 1 in front of this, because if I only have one substituent around the ring, that substituent will always inherently be 1 because I want to give it the lowest number. So I could just call this ethyl cyclohexane if I wanted to. Now, that situation changes as soon as I start introducing more substituents, right? So let's say, going back to the same sort of example, I have this here, and then I decide to do a chloro here, and I also have a chloro here, right? If I want to give the lowest numbers here, this would be 1, 2, 3, 4. So I'd have a 1, 2, 4. Keep in mind, if I went this way and I numbered this 1 at the ethyl, it would be 1, 2, 3, 4. So I would be dealing the other way around. I'd be dealing with a 1, 3, 4 situation. That's higher in numbers. We always go for the lowest set. So if I wanted to name this, now I do need to bring numbers back into it because it's not clear where all of these are relative to one another. So if I wanted to name this, C, chloro, is going to come before E, which is ethyl. So when I get ready to do the naming, I would say, all right, I've got a 1, 2 dichloro, and then I can say I have a 4 ethyl cyclohexane, and that would be the name of the compound. Okay, so hopefully you guys are finding this useful and helpful. I will definitely put up 1 or 2 practice sessions so that you guys can pause the video, work on it, and then see the solutions worked out. One other thing I wanted to mention real quick. There are several other groups that you can run across quite often. You can have isopropyl, and these are special substituent groups where you would have an isopropyl group is going to look like this. So you would have a CH, CH3. Keep in mind that when we put R stands for the rest of the molecule when we're looking at that. So if I had a group that sort of looks like this Y branch coming off of a main chain, that would be an isopropyl group, right? And here's R. I could also have an isobutyl group. So butyl is going to have 1 additional carbon. So that would be something like an isobutyl group, right? Because here I have 1, 2, 3. That's propyl. Here I have 1, 2, 3, 4. So that's butyl. Now, look at the branching that occurs here. That's what gives the iso formation when we're talking about this, in comparison to just regular propyl or regular butyl, right? Regular propyl would just be a 3-membered chain like this, coming off of some R group. And then a regular butyl would be a 4-membered carbon chain coming off of some R group. All right. So there's 2 others. There's actually technically more than 2 others, but the most common ones you're going to find. You can get sec-butyl. And when you have sec-butyl, you're going to be talking about a butyl. So it is a 4-membered carbon. and you're attaching it in the secondary position here. So this carbon that's sort of 2 spaces in, this is secondary relative to these positions out here, which are primary, and you can also have tertiary positions, which is the other one. So you can also have a t-butyl, and the T stands for tert, or tertiary butyl. And a tert-butyl looks actually just like a T. Okay? So what we're really looking at here, if you take the R group, in one case we're dealing with something that would be CH, CH3, CH2, CH3. That would be a sec-butyl group. A t-butyl group is going to look like R, again R being the rest of the molecule, CH3, CH3, CH3. Okay, and then you can have, they have things that are called neopentyl and all sorts of stuff, but you should be focused on these four, the 2 isos, isopropyl, isobutyl, and sec-butyl and tert-butyl. Just to make it a little bit screwy, because that's what organic chemists like to do, either of the iso compounds, when you're naming them, they get ranked as I in terms of their alphabetical ranking. When you deal with ranking the sec and the tert-butyls, as far as their names, you don't count the sec and the tert because it's referencing their relative positioning, whether they're secondary or tertiary. And so you only classify these with B for butyl. Okay, so the isopropyl and the isobutyl get classified as I when naming. The sec-butyl and the tert-butyl would be classified as Bs when naming. You just have to be aware of those sort of minor discrepancies, because if you're working on a homework or a test or something like that, you can get marked wrong, technically, if your professor sees that you're switching these up or you're not paying attention to that sort of stuff. So there may be something else, but I am going to cut off the video here because we're already at 22 minutes. If there's additional questions, leave them in the comments section. I will be happy to tend to them and probably do like a follow-up video of some sort, but I do want to get some practice started with this stuff. So please remember to like the video if it was helpful. I really want to ask you guys to subscribe. That's the way you'll get the latest information from me. And thumbs up the video if you found it helpful. Feel free to leave comments, and thank you very much for taking the time to learn with me. I will see you guys for the next lesson. Take care.